tanks, the H tanks that look like bombs, when they're full, it's still 2,200, 2,100 pounds per square inch, but you can't divide by 3 to find out how many liters are in it. It only works on an E tank. So the other way we can get oxygen in is going to liquid outside, and we gas it in, or we can have an oxygen generator. When it comes up here, we attach this tank to the anesthesia machine using a safety index pin index system, which is incorporated into the yoke. And that's what this square thing is that you screw the tank on. It takes a washer to hold it. The pins prevent you from putting the incorrect tank on. Oxygen in this country is green, in other countries it's white. The machine can't use oxygen at 2,200 pounds per square inch. And as you use oxygen up, the pressure goes down. So the next place it goes is to the pressure reduction valve here. Preset at the factory, it reads the pressure on top in the tank, but it provides oxygen to the machine at 50 pounds per square inch. If you have a tank room and you're on the wall, then you have to set your line pressure at 50 pounds per square inch. Although some machines can use higher, most of these are set at 50. After it goes to the pressure reduction valve, the next place it's going to go is the flow meters, O2 flow meters. Color-coded, tactile-coded, so you can feel which one's which. Over here it's in liters, here it's in mils. Small animal machines go up to 5 liters on one side and up to 1 mil on the other side, or 1 liter on the other side. They're additive. If I turn this to 2 liters and this to 800 mils, it's 2.8 liters of oxygen per minute. These are graduated. At the top they're lighter, so as that ball goes up, more oxygen you can apply it. You read the balls right in the middle, you read the bottom ones at the top. After it comes through here, it goes to the vaporizer. It's a precision vaporizer. It puts out anesthetic agent within 10% of what it's dialed. It's a variable bypass vaporizer, which means that when it's turned off, all the gas goes straight across. When you turn it on, it goes down and picks up some of the vapor that's down here. Depending on the vapor pressure of the agent, divided that by atmospheric pressure, you find out there's 33% isoflurane vapor in there. The MAC of ISO is 1.4%. That keeps 50% of animals anesthetized for light surgical stimulants. You only put a little bit in here to get what you want. You dial in here and it comes out here and it goes to the fresh gas line. So these two things, if I pull, can make them, they go back and forth. I hit the O2 flush, it dives down in here and it bypasses the flow meters and the vaporizers. As you vaporize this stuff, it makes the vaporizer get cold, so it's temperature compensated also, because when it gets cold, less vapor comes out. Okay? If you put the incorrect agent in, you have to open this up, turn this over, drain it out, and then you have to turn this on for a couple hours and turn the vaporizer and the oxygen on to dry that wick and the baffles out. If you tip this greater than 45%, you can get the agent up here in the bypass. You have to just turn the gas flow up, it goes through here and dries it out. Book says 20 minutes, it usually happens in 2 or 3 minutes. Otherwise, the patient would be breathing 33% ISO if you tip this over. After it comes out here, the fresh gas line, I turn this to 2%, I got 2% right here. Then we have to have different ways for the patient to breathe. So we use either non-rebreathing or rebreathing. This is a rebreathing machine. It's a circle system, it has valves, that's how I know it is a circle system. I can see the valves. I hook up my adult above 9 kilograms for the breathing circuit. Below 9 kilograms, we use a pediatric. And if we get down to 2 to 3 kilograms in, I can't use a circle or the rebreathing system because there's too much resistance and dead space in this system. I have to put a reservoir bag on it. Breathing bag, we determine the size of this breathing bag by the patient's weight. It's 6 times tidal volume. One number for tidal volume is 10 mils per kilogram. So if I had a 10 kilogram dog, 10 mils by 10 mils per kilogram times 10 kilograms means his tidal volume, one breath, is 100 mils. Take 6 times that. The rebreathing bag, or the reservoir bag, should be 600 mils. They come in half a liter or 1 liter. You always go to the larger size. You never go down. Put that here. When I turn the oxygen on, and I hook this up, oxygen comes in here. When you take a breath, the inhalation valve opens, the exhalation valve closes. That way, nothing can go down this way if this is closed. When they exhaled in, the inhalation valve closes and the exhalation valve opens. So when they exhale, it can't come back up here. Makes everything go in a circle, and that's what prevents you from rebreathing CO2, except for this bit of dead space at the top of the white piece. When the gas comes up here, it has 2 places it can go. It can go through the pop-off valve, and come out to the scavenge, our preferentially wants to go where there's less resistance. So on this machine, it comes down and percolates up through the soda sorb. Depending on how much oxygen I put in, will determine how much comes out and go to scavenge. Soda sorb chemical reaction produces heat and water. As this is used, it gets warm. If I could reach in and feel it, as if it's used, it's hard. You can't crumble it. If it's new, it's soft. If it's working, it should be warm. You change this when the color indicator is halfway. Once it goes through the soda sorb, it comes back over here in the reservoir bag, and we add a little more iso and oxygen, and it makes a circle again. The minimal amount of oxygen I can put in is based on the animal's metabolic oxygen requirements. That's 2 to 3 mils per pound or 4 to 6 per kilogram. If I do that, it allows me to close this pop-off valve and leave it closed. It doesn't have to be closed, because when I just put the minimal amount, what the animal needs, it all goes down and around, and that's called a closed system. A closed system allows me to close this pop-off valve, but it doesn't. To close the system, I don't have to close the pop-off valve. To close the system, I have to lower the oxygen flow rate. Got it? That's important. O2 flush will change the concentration of this. If I turn this from 0 to 2%, the animal's not breathing 2% for quite a long time, because it takes a while for this to build up to the percent you're putting in. So the advantages of this, I can go to low flows. Low flow means I'm close to the metabolic requirements, or I can go to a closed system at the metabolic requirements. So I don't have a lot of pollution, I don't waste a lot of oxygen, I don't spend a lot of money on ISO. I can close the system, it keeps heat and humidity in so the patient doesn't get as cold. Disadvantage, if I want to go from 2 to 3%, it takes a long time to get to 2 or 3% when you make changes. But it's more economical. Now, if I have a small patient, then I have to go with a non-rebreathing system. A non-rebreathing system usually is called a Baines. I'm going to put the Baines system on a Bain block. I'm going to hook the Bain block up here. I'm going to hook my fresh gas flow up. This tube goes in here, exits down here, and makes a U-turn. The gas makes a U-turn and fills this up. The patient breathes from around what's around that blue tube in here. What gets rid of the CO2 in this is a high gas flow. If gas flow is too low, you'll rebreathe CO2. You also have to put a reservoir bag on it. You never use a 3-liter bag on a Bain system, because Bain system's a small dog, so it's usually a half or a 1-liter bag. Pop-off valve has to stay open in this one unless you give them a breath. You can never leave it closed. And look at, I didn't show you this, but look how, on the circle, remember how I had to screw to close it? This one is just, that's it. Why doesn't this one have to screw all the way down and come back up? Why do they only make it open and close with that little bit? Because of high flow rate. Once you close this down, you got to open it up right away, or else you get baritone really quick. Okay? Advantages to this: very little resistance, very little dead space, good for small animals. Disadvantage: high flow rate burns oxygen and ISO quicker. Animals get cold because they rebreathe every bit of gas that they exhale. So we don't use this that often. We really don't do that. It means really, really small animals. Okay? Does that help? I'm going to leave this up here. You guys should come up and look at it. If tomorrow, we're going to start monitors tomorrow. If you've got questions, you can go over this a couple of times, and if you want to,